These are the solutions to homework 55, where we're going to be using a lot of multiplying of complex numbers and dividing complex numbers, and also complex numbers raised to powers and finding their roots. So it's going to be using a lot of trigonometric form and also standard form of complex numbers. With problem number 36, we were asked to graph this point. And so you can see that we went to a radius of 8. I counted these out, and I went to a radius of 8, and I found on the spoke of pi over 12, and there it is. That's the point. But we were also supposed to find the standard form of this point, of this number. And since it's not a known, since pi over 12 is not one of our known angles in the unit circle, we're going to have to use our calculator to find that out. So we have to find the cosine of pi over 12. And granted, we could use like half or double angle formula, or half angle formula or something like that, but just you're allowed to use your calculator and come up with a decimal approximation for it. And then we distribute the 8, and that's your final answer. For number 37, you're to graph this, and so we're spinning around this till we get to 3 pi over 2, and then we go out to a radius of 4. Remember, that's really called the modulus, but we think of it also with polar graphing, that's a radius of 4. And we're also to find these in standard form. We know 3 pi over 2, so we know the cosine of that and the sine. Distributing the 4, we get negative 4i. Now, I want you to think about that for a minute also, because really this is graphing in a complex number. So our axes are the real axes and the imaginary axes. And if I had asked you to graph this number in the complex plane here, you would say, oh, well, that point right there is negative 4i, which is exactly what we got computationally. The next problem is to multiply two complex numbers, where this is the first complex number and this is the second complex number. And there's a rule for the product rule of two complex numbers. It says if you're going to multiply two complex numbers, what you do is you multiply their modulus and then you add their angles. So in this particular problem, our modulos are 3 and 4. So we're going to multiply 3 times 4, and the angles are pi over 3 and pi over 4, so we add those two together. You've got to do a little bit of fraction work, but pi over 3 plus pi over 4 is 7 pi over 12, finding a common denominator. And that's the final answer. It did not say to write this in standard form. It said leave it in trigonometric form, and so that's all we do. For problem number 49, it's the same idea. We have our first complex number right here and our second complex number. So we multiply our the modulus, and we've got that here. We add our angles, and we have that, and there's our answer. For division, we have what's called the quotient rule of complex numbers. The numerator is always our first complex number, and the denominator is our second complex number. The quotient rule states that when you're going to divide one complex number by another, you divide the modulus, and then you subtract the angles, where you're subtracting the numerator minus the denominator's angles. So we need to find out what the modulus for each of these complex numbers is. Well, it doesn't have a number out here, so it is 1. The modulus of both of these complex numbers is 1. So we're going to have 1 divided by 1, and then their angles, we've got the numerator is 40 and the denominator is 10. So we're going to have 40 minus 10. And so our final answer is sine 30 plus I sine 30. In problem number 57, we divide the modulus, and 12 divided by 3 is 4. We're going to subtract 52 minus 110, which is negative 58, and so there we get the answer of 4 cosine negative 58 plus I sine negative 58. For problem number 59, we're going to multiply these two complex numbers, but they asked us to do several things first. And the first thing was to change both of these complex numbers into their trigonometric form. And so we have to find the modulus for 2 plus 2i, which is going to be 2 root 2. And thinking about that, if I'm going to go over 2 and up 2, that's going to give, so you don't have to use your arc tangent. You should know that this is going to give you the perfect diagonal, which is pi over 4. And for the second complex number, we have a 1, negative 1, which means we're going to have a radius, or the modulus, of root 2. And If we went over 1 and down 1, that's going to put us in quadrant 4, so we're going to get 7 pi over 4. And then we use that same rule of the product rule. We're going to multiply 2 root 2 times root 2, and that's going to give us 4. We're going to add pi over 4 and 7 pi over 4, and that's going to get us 2 pi. But remember that 2 pi is the same thing as 0 radians. And it's better to keep things less than 2 pi, something between 0 and 2 pi. And now we had to check our answer by actually doing the multiplication in standard form. This is the method I like to do when I stack them, and I multiply straight down to get my reals. So 2 times 1 is 2. 2i times negative I gives me positive 2. And then I multiply across the cross to get our imaginary portions. Collecting all of these blue numbers together will give me the final answer of the product of those two complex numbers in standard form, and it's 4. And we're supposed to check that with the answer we have up here. So we're going to have to actually simplify this out. And of course, cosine of 0 is 1, and sine of 0 is 0. So we're going to distribute the 4, and we get 4, and lo and behold, it does check. They are correct. Problem number 62, we do the same idea. We find the modulus for this 3 plus 4i, which is going to be 5. It's not a known angle in the unit circle, so we're going to have to use arctangent to come up with this angle, and this angle is in radians. I'm using radians. I prefer to use radians. And to do the division, we're going to divide the modulus. We're going to subtract those two angles. I'm going to use my calculator to help me with that. And we get that the radians are negative 4.3087 radians. We need to check it by actually doing the division of this complex number. But recall that division of a complex number is actually just rationalizing the denominator. So we're going to multiply by its conjugate pair. And yeah, it's like, ugh. Now that we're learning this wonderful method, it's like, oh, this becomes like, ugh, I would never want to do this anymore. I much prefer using the trigonometric. I much prefer this, and so now I simplify it all, and I get this wonderful, wonderful answer, which has just got all of this. And yes, we really should simplify this a little bit more, and we'd write this as 3 minus 4 root 3 all over 4 plus 3 root 3 plus 4 over 4i. And then you could plug all that in and check the decimals, and sure enough, the answers are exactly the same thing. We're now going to raise a complex number to a power, and so we find its modulus and its angle. We raise the modulus to that 5th degree, and then we multiply our angle. And simplifying that out, we can find the cosine of 5 pi over 4 and the sine of 5 pi over 4. And distributing that, we get 4 minus 4i. The answer, or the question was given in standard form, and so we should answer in standard form as well. We have 2 plus 2i with a modulus of 2 root 2 and an angle of pi over 4. Raise the modulus to the power of 6 and multiply the angle times 6. We're going to simplify and distribute, and we get negative 512i. For this next problem, the first part of this is we look at this complex number raised to the 7th degree, and we're going to take care of that, and then lastly we will distribute this 2 afterwards. So using our rule, we have the modulus, which was 2, and the angle is pi over 6. We raise the modulus to the 7th degree because that's the power we're asked to expand this out to. And here's where we now can do the distribution of the 2 times the 128, which was 2 to the 7th. And we get 256. And we have cosine of 7 pi over 6, which is a known because that's in our unit circle, and a sine of 7 pi over 6. We're going to distribute, and there's our final answer. For problem 81, it's the same idea, except now we have, and these are radians, 3.2 radians, because there's no degree symbol. So we're going to have to use our calculator and just plug that into our calculator and get some decimal answers when we do this problem. We take our modulus and raise it to the 4th, since this is to the 4th degree. So we raise our modulus to the 4th. We multiply our angle using the calculator to do the computations. We have our final answer. For 93, you're asked to find the fourth roots. Remember, that's plural. And since it's fourth, there's going to be 4 answers. We take the modulus, raise it to the 1/4 power. Since it's a root, it's the 1/4 power. We take the angle and we multiply it times the 1/4, simplifying. And that is our first of 4 answers. And they're going to be evenly distributed around the circle, which means all of them are going to be 2 pi divided by 4 radians apart from each other. And there's a little bit of fraction work to do, and so we're adding those. We're just going to keep adding 2 pi over 4 to each of those angles. And when you do that, you come up with those 4. We're then asked to graph. So on our polar graph, I've graphed those 4 points where we have this angle right here, which is at pi over 3. It's a radius of 2. So you can see my scale. So here's the radius of 2. So I went radius of 2, pi over 3. Then we did 5 pi over 6, then 4 pi over 3, and lastly 11 pi over 6. So those were our 4 answers. And we also had to answer in standard form. Our last problem was the cube root of 8. We've got a modulus of 8 with an angle of 0 radians. We raise the modulus to the 1/3 power. We multiply our angle times the 1/3, which is pretty simple since it's 0. And that is our first of 3 answers. Since this is cube roots, there's going to be 3 answers. And since there's 3, we're going to be adding 2 pi divided by 3. And so, again, it's nice because we're just adding it to 0. So we've got 2 times cosine of 2 pi over 3 plus I sine 2 pi over 3. Add another 2 pi over 3. And now we have our 3 answers, which we're going to graph. So now we've gone to a radius. In my scale here, I've got 1 and then 2. So this is the radius. I'm counting this one as the radius of 2. The first answer was 2 with an angle of 0 radians. The second one was modulus 2, so I've got to the radius of 2, with an angle of 2 pi over 3. And the third answer was, again, the radius of 2 and the angle of 4 pi over 3. We also had to answer this in standard form, and so you can simplify each of those. You can find the cosine of 0 and the cosine of 2 pi over 3 and the cosine of 4 pi over 3 and simplify the whole problem out. And that's the answers to this homework assignment.